This is a step-by-step guide to CoPerspective. So when you download CoPerspective and unzip it, you'll get what you see here. Two demos, the .NET installer and the xbuilder.exe. Demo A is a Gravity program for Windows, and Demo B is a larger, secure chat program for Windows. So let's start up xbuilder.exe here. So here's the main build tab for rebuilding EXEs or DLLs, and we'll click Add, and we'll re-X-ray the Demo A program, old-fashioned fun. So I'll select that, and there's some options here, different things you can track or not track. We'll select decompile to C# because that's pretty useful, and we're not going to overwrite it because you only really need to overwrite DLLs or WPF apps or ASP apps. Yep. Okay, so let's recompile it. It's recompiling, and okay, so it's recompiled, and this analyze button here is for static analysis. So we're just taking a look at what was X-rayed. We're not actually running the application. And what was created in the Demo A folder was the X-rayed version of the executable. The support files here, this is for OpenGL rendering, this is for OpenGL rendering, this is the visualization tools and everything, and this is the static analysis data. So we will start at the application. Very simple application, just one little button here. And here's the visualization here starting up of that. Cool. Okay, so we don't actually need to run the visualization all the time. You know, it uses CPU power, so we can close it when we don't need it, and you can use this option here, show viewer when app starts, and you can turn it off if you don't need the viewer all the time. If you just want to use it on demand, you can use the monitor tab, and the monitor tab will show you any program or DLL that's been X-rayed, and it'll let you start up the viewer on demand, or multiple viewers if you have multiple monitors. So we'll start the viewer back up. There we go. And the scanner tab will let you look at any directory in your system and find out what files in that directory are .NET assemblies. So it's useful if you don't know if a .NET or DLL is something that can be X-rayed. Use a scanner, find out what you can inspect, X-ray it, and then use the monitor to start the visualization. So that's all we really need the XBuilder for. We'll go right to the visualization here. I'll make it bigger. Okay, so first thing I'm going to do is switch it to OpenGL mode because that uses less CPU power, but it takes longer to initialize. What we have here is our main window. We're looking at the tree map layout that's selected here. These black labels are files, these blue labels are namespaces, green label is a class, red labels are methods, and yellow labels are fields. We can double click on this class to zoom in on it, and you'll see these breadcrumbs up here reflect what your current zoom level is, so we can zoom out to this old-fashioned fun namespace. And this button right here is to filter the view on specific threads. So right now it says we only have one thread running, the main thread. But if there are multiple threads here, you can select that and it would only show down here what methods hit that thread. And here's the search box up here. So if I was looking for the bounce function, I would click bounce, type in here bounce, and there it is right there. There's some advanced options for the search, like highlighting subordinates. So if I was looking for the main form, it would highlight everything that's a sub of the main form, which is useful when you're looking at maybe a class view or a method view. You know, you don't see the main form here, but everything highlighted is a subordinate of the main form, and it's blinking. See, when I didn't have this selected, nothing would be blinking except methods that match that name. Okay, so back to the tree map visualization. So the other visualizations, we have the layer graph, which takes each piece. You see here from, if we look at the tree map view, you can see there's one namespace and there's multiple classes here: main form, Win32 class, the properties namespace. So each of these levels are made into graphs, and that's what the layer graph is about. You see we have the main form class, the properties namespace, are all on the same level, and so they're in the same graph. And then when we zoom in here, we can see everything inside the main form part of the tree map has its own graph down here. So everything is graphed and subgraphed, and it's a really good view for looking at very large applications and seeing how everything is organized. Next view is the threadlines view. So what we have here, every column is a thread, and in this application we just have one thread, and the subcolumns here are the method, the call stack for that thread. So you can see, that's just zoomed in when I double clicked on it. You can see here the main function called the constructor, the constructor called initialize component, which accessed all these fields here, and called this get bike function, called that, called this, called that. And you can see when I turn the program on, I'll hit toggle gravity here, more things will be added to the call stack. I'll start running. So when I click for example, when I click the button click function, it accessed the gravity enabled function, which if I mouse over here I can see gravity enabled is false, and it modified the timer, probably turned it off, and things like that. The initialization layout is probably the most useful for looking at a program's architecture. If you have like a really big program and you look at the when I think of an application, when I was building this program, I was trying to have the visualization produced match what was in my head for like larger programs like DOPS, for example, which is included. It's a big program, and you know, I first started the program with a method graph and the tree map, but those visualizations didn't match what was in my head, and I found out that it was the initialization graph that really matched how I thought about the program structure. And the initialization graph is the graph of which class initializes which other class, and that chain, even in a big application, is pretty simple to understand, and it gives you a good idea of the overall architecture of the program. So definitely a useful class. Check it out with your own programs, the initialization layout. The class graph basically is a graph of just every class in the program and how the classes talk to each other with the methods and fields inside of them. Now you can turn off the methods and fields inside of them by going over to this include area and turning off methods and fields. By default they're on. And then the method graph layout is the most complex graph when you're looking at everything at a time, but when you're zoomed into something it's a lot simpler. So here's the method graph layout, and we can turn on this calls option here to just show the calls. By default it's off, just to just show the real-time calls, but yeah, it's usually just turned off so you can show the real-time calls, because when I turn the program on again here, you'll see things start moving, and when you have the calls on as well, it's kind of distracting. So I'll turn this off. The method graph is more useful when you're zoomed in on something. Like I'll zoom in on this get height function, and I can see, and I'll turn on the calls view again, and I can see what functions call get height and what functions are called by get height. So that's a pretty good use for the for the method graph. Not much so for the for high-level views. In that case, I'd suggest going to the class graph or the layer graph. Okay, so some more notes on actually using the graphs. Let's take a look at our method graph here, and I'll turn the calls on so we see what calls what. You can see that the main function is the original function that the program started from, and it's green because that means that's the first place the stack was observed to be created. So anything highlighted green is the first function called by a new thread. Now let's look at the not X-rayed stuff. So Code Perspective can look at function calls through stacks that go through things that weren't X-rayed and back into our program. So I'm going to turn on not X-rayed here, and you can see anything that's a triangle here is a method that is not X-rayed, that we inferred, that we saw that was called, but we weren't inside of it to actually track it. So with not X-rayed selected on, we can see the main function was started, the thread was started with the main function, which called the run function, Windows Forms application run, and the run function is our event loop, and you can see the run function here is what's calling button click step timer.tick. See, when I have not X-rayed not checked, you can see step timer here, button click here, and you see it's not really being called from anything, but you know it's being called from the run loop. The run loop function is something that wasn't X-rayed, so that's why we check it. Oh, we can see, okay, that's what's calling step timer tick, that's what's calling button click. And actually, if we zoom into the run function, we can see it's shaded yellow. Now, yellow means we can detect that the call stack is held up in this function. So yellow means holding. Green means it started here, and anywhere you see something that's yellow, that means the code is probably spinning inside of it right now. Another note is anything that's shaded gray in the graph is outside of our zoom. So for example, if we zoomed in on the main function, anything gray here is outside of our zoom. And yeah, you can kind of like surf through an application just by going from double-clicking on method to method to method. From this main, I'll double-click on run, double-click on button click, see what that fires, and so on. So it's pretty useful. Okay, so now we're going to look at the dependency map layout. In this view, you can see each class in the program, and when you select on that class, you'll see the dependencies in relation to it. So I'm clicking on this main form class, and we can see that it is independent. It is dependent on the Win32 class and dependent on the resources class to run. And when we click on the Win32 class, we can see that the main form. When we click on the Win32 class, we can see the main form is dependent on it. So red means something is dependent on that thing, and blue means something is independent of that thing. So I clicked on Win32, main form is blue, that means main form is independent of the Win32 class. And purple means it's interdependent. The depends graph is kind of the same thing, it just shows you kind of the same information but in a chart. So you can see that this program class is dependent on main form and Win32, and main form is dependent on Win32 and resources, but independent of the program class and interdependent on itself, of course. Okay, when the subdependencies checkbox is not checked, it'll just show you, when you click on something, it'll just show you direct dependencies. So Win32 is directly independent of the main form, but when subdependencies is on, it will show you the entire chain of dependencies. And then interdependencies is if you want to look at the dependency graph between two objects. Say I want to see the dependency graph between program and resources. I click on program, I can control click on Win32, and I click on interdepends view, and it'll just show me straight through the dependency chain between those two graphs. So if you have a really big program with lots of classes and you select two classes at opposite ends, the interdependency view will show you the dependency chain between the two. Okay, so on to rendering. GDI looks the best, but it also uses the most CPU. So I usually turn it to OpenGL mode, which is faster, but sometimes has some rendering issues. And the Gibson view is the 3D view. With the Gibson view, you can you can press the M button, and it will give you a mouse select view. So you have your WSAD controls the crouch, spaces to go up, WSAD is to strafe and go forward and back and all that stuff. This isn't too practical, but it does work on all the other views, tree maps and layer graphs and thread lines and things like that. For really large programs, there's some optimizations here with the 3D stuff that's not done yet, so it's going to be, the frame rate's probably going to be pretty low. So to improve the frame rate, at the moment, this pause button will pause rendering, and it will make it a lot faster, the rendering of this Gibson view. But it also pauses rendering, so there's no actually live updates of methods getting hit or anything like that. Down here is some performance, kind of used for just diagnostics, but you have a frame rate, and then a number of times it's kind of resizing and redrawing the views, things like that. Okay, let's go back to the tree map view here, OpenGL. Okay, so going over to the element section here, this element section is to filter on things. Right now it's just showing everything, it's selected all, but if we select executed, we'll just show what elements have been executed so far in this run. If we click on not executed, it will show us what fields and methods have not been executed yet this run, and this initialized filter here will just show us classes that have been initialized so far this run. This reset hit button will reset what's been executed, what's been executed. So if I hit reset hit, everything will be set as not executed, and so I can kind of trap like button presses and things like that. I can set everything to not executed, click a button, and I can just see the execution path of what happened when I clicked that button. So for example, I'll go to executed, but I'll click reset hit. Now nothing is set as executed, and I'll turn the program on, and you can see everything shows up that has been executed, while the constant filter shows everything. This executed filter just shows what's been executed. Not executed filter shows these things haven't hit yet, and so on. So this is actually pretty good as well for code coverage. If you want to go through your program interactively and try all the features, you can keep an eye on this not executed view, and try to do things in your program that will get these functions to be run and things like that. Okay, I'll turn the program off. Yeah, let's go through the views of the program on one more time. So here's the method graph, class graph, initialization graph, thread lines running, layer graph, of course zooming in works and all that, mouse wheel, and the tree map. Okay, so this show area here will show us, this calls checkbox will show us what calls have been made between functions. So in the tree map view it doesn't look very good, but in the layer graph it's pretty useful, or in the method graph or the call graph. If you don't have the program running, or it's not, here's it running and it's kind of intersecting and doesn't look that good, so I want to turn the calls off. But if there's not much going on, then I'll turn the calls on to actually see which functions call which other functions, which functions call what fields, and so on. Actually, that reminds me, I haven't gone over the colors yet. So let me go back to the tree map view, turn off the calls, turn the program on. Okay, orange is methods getting hit, and green is fields being accessed, and blue is fields being set. So that's just an overview of the colors. There's also red in here. If an exception is thrown on a method, then you should see a red flash in the method. So let me go back. Okay, so the real-time checkbox, obviously these These calls are the real-time view of what's going on, so if I turn it off, they're hidden. And turning off the real-time view is pretty useful in the tree map view if you just want to see a blinking kind of interface of what's running, what's not running. Also might want to filter just what's executed, so you're just filtering, you're just watching exactly what's running, what's being accessed, what's not being accessed, stuff like that. There's an order checkbox here is for the method graph. I turn the program off, show the calls and things like that. So for example, this main form constructor called these fields, but when in order is checked, it actually shows you in what order the calls are made, top to down. And when in order is not checked, these fields could be in any order. They're spaced out in a way that optimizes the graph in relation to other components in the program to make the graph look like really good. In order kind of sacrifices the layout niceness to show it top down what things were called in what order. So usually it's not that useful to have in order on unless you want to see the step-by-step methods or fields that were accessed. Code will show you the code in the function or the value in the field. So if I zoom in, I just turned code on, zooming into the main form constructor, I can see the code of that constructor, or zooming into the field, I can see the value of that field. Okay, the include section, the outside zoom checkbox, and right now we're zoomed in on the main form constructor. Let's zoom into just the main form class and then go to the tree map. So now we're just seeing the methods inside the main form class. If you click on outside zoom, we'll see everything outside of the main form class, so our Win32 class and our old-fashioned fun namespace and things like that. And the not X-ray checkbox will show us calls made by a program into assemblies that have not been X-rayed, so our MS core lib, system namespace, collections, generic namespace, things like that. And we can see calls. So if I turn on the calls checkbox, we can see calls from our program outside of our X-ray assemblies into not X-rayed assemblies. So that's what this checkbox will do here, is show our not X-rayed assemblies. Okay, so methods. I'll zoom out here. This methods checkbox obviously will toggle the showing of methods. Fields checkbox will toggle the showing of fields, and the anon checkbox will show us anonymously created fields and anonymously created classes, anonymously created anonymously created classes, fields, and methods created by the compiler. It is pretty useful because sometimes in between two functions there's an anonymous method or field that's getting called in between, so you want to turn that on. So yeah, that's pretty useful. And the size by column here, or section here, right now everything's sized by a constant amount, sized by lines, everything's sized by in proportion to how many lines are in that method. Now everything's sized by how many calls are made to that method or field, and you can see this bottom tooltip here. In this one it was about 400,000 calls to this integer top here, or 277,000 calls to this getWith function. You can also size it by the time spent per call, or the time spent total in accessing this method or field. So let's put it back to constant sizing here. Okay, so the details tab depends on what you're selected on. So if you're selected on a field, it's going to show you details for that field. So I selected on this down acceleration field, and I can see there's one instance of it. It's a double, and its value is 12,000. If I select on a method like test shelf, I can see the C# code here. And if you click on the blue hyperlinks, it'll take you to the the corresponding Win32 point. I clicked on that, it took me to the point class, which wasn't created. There's a missile option here, just if you want to see the missile code, which also has hyperlinks in here. And this stuff is actually pared down, which, if you've actually seen missile code, this is actually formatted, so it's a lot easier to read. It's filtered, so there's a lot less cruft here, and it's just it's pretty easy to read. And then the profile tab will show you calls into the function you selected, and things your function selected called to, and the amount of time it took when it called that function, and the total amount of time. So this is the profile view here. And when you select a class, the details tab will show you all instances of that class. Right now you just see this one instance of the main form class, and it will show you its declared type, selected type. Sometimes if it's like a subclass or something else, the declared type will be different from what you actually selected. How many instances there are. Right now it says up here there's one active instance, one's been created, none have been deleted. So here we'll keep track of how many instances of a certain class have been created or deleted, how many are active right now. Just like a debugger, you can go into the base type of that class and see the real-time values of the base type. And here's all the values, or all the fields declared in the class and their values, and you can select on anything here, and you can go into its details and things like that, just like you broke into the debugger. You can also select just look at the methods inside the class and how much time each method took. And that's a similar view to if you just selected the namespace. It will show you the namespaces and the subclasses of the namespace, or the file. Also show you the namespaces in that file, so you can interactively just go into one namespace into the class, kind of surf through it like that. The console tab has a bunch of different debugging commands in here. I'm not sure if I'm going to go into any of this stuff. The log is kind of like a debug log. Help will show you the available commands. Stacks will show you, it says like stack, there's thread 1 and there's two things on the stack. One has an ID of 19, and IDs correspond to functions or fields, so I can type in ID 19 and it should resolve to what it is. That's the run function. ID 19 is the run function. Or I can find ID, run, and I should find any methods or fields with that ID. So the console is kind of like a debugging thing. So that's that. And the About tab will show you news and updates in this panel here, copyright notices, what programs were built, what programs were used in building Code Perspective and their respective copyright notices and things like that, and your current license, which is AGPL. By default, when you download the program, everything you build with it is AGPL and should be open source. And if you want to, use your proprietary software and use X-Ray with it, then please buy the Pro version, and that will let you build proprietary stuff without having to make it GPL. So yeah, that's a pretty quick overview. Not a quick overview. That's an overview of Code Perspective. And if you have any questions or comments and things like that, there's a forum on the website. And maybe in the future I'll make some more videos with different applications, and we can go through everything interactively and do some exploring.